I spend more time on the piano.
Next thing I pick up the guitar.
No, my son plays guitar, and he's showed me some things. I play around with it.
Oh, you also play guitar?
Well, I know guitars.
Okay.
I know music. I play piano. I play percussion. I can fake it on guitar, do rhythm, hanging out with people. But I know the history. I know the art.
We're just setting the tone. Sorry, yes.
Good morning. All right.
Let's not have too much fun.
Yeah, careful. No fun. Let's see. It's going to convert. It detects it. It's probably just in standby. What's that? We have a volunteer?
Yeah, for minutes.
What wouldn't I do for an exchange?
We did it. No, we have a Holly Fat Boy.
Bring it. It's in my hotel. I do have an extra bottle. I was thinking, why should I bring it? I don't need to bring a bottle this morning, and it's for minutes. Oh,
I'll offer you a draft.
You'll
in the bar.
Yeah. So we're getting up there. It's not even centered. All right. There we are. Good morning. We're still rolling in. First of all, I'm impressed that you're here on a Friday. We had to pay our dues. We've been avoiding it for a bit, but IETF agenda is spilling off into a full week now. We still have people coming in. We've got a pretty full list of things, and I hope we got some good dynamic interaction, and I want to use every minute. So, well, I thank you right through that thing, huh? Note well, noting well. Look at that. See, I told you put it up there. It's almost reasonable. We have a minute taker. Correct? We're in? All right. So start with the agenda here. Bash if you can. Make sure I got all the items well represented. This is the order we're going to go through them. So Tony, you'll be up first. Right. Yeah, Ice is here. Greg's here. Is Greg here? Yeah, there's Greg here. Ran Chen here. Ran Chen. Yep. Okay, good. The man with no tour. Yeah, tourless will come in like 30 seconds after he's supposed to start. It's pretty traditional. Sandy and Linda. Gotcha. All right. Okay, good. We're up. So everything's on. Let's start with Tony.
Okay, so it's one view graph only. Les is here. Let's see. Yeah, so Les is the editor now for the ISI's document. The only thing that happened, we added a sub DLV to advertise whether a router can do a BSL conversion, because the architecture has been extended for the BSL conversion. And the architecture specifically says you should not announce that, but we put it in nevertheless. And this thing will not be advertised today, but it will basically clarify the semantics should the issue come up that not advertising it signifies it's not supported. And if a router advertises it today, there's nothing you can do because you don't have the computation for it. And that's pretty much it. Yes.
That's one slide. Can you say it with the mic? I got a question for you.
Okay. Yeah.
So we might have a chair chat here, but things that are going to come up soon is status of documents. And so what you're feeling in terms of how mature this is and ready for, when we get to last call.
Comments?
Comments from the room?
I mean, the only thing necessary is pretty much the architecture alignment, but I mean, that's a minor thing.
Okay.
Right.
All right. So, because my expectation would be the IGP drafts are probably the closest we've got. There's not much to do there. Architecture draft is going to probably stay open for a long time until we wrap stuff up.
Yes.
And we
Well,
have new stuff that's coming. We have to decide to adopt, and most of that's going to take place today.
But I
But
mean, what's the point rushing this thing? I mean, I don't see implementation coming up.
no, I have no intention of rushing it. But you did hear Aaliyah talk about not letting groups go on forever either, right?
Yeah.
So
No, but I mean, on the other hand, last call this thing before we have implementation experience. No, we may. What's the point making a biz, right?
Yeah.
I'd rather have like 1 or 2 implementation rolling in. People beat me up because then I know I'm in a good shape, right?
actually, that would be refreshing because it used to be the requirement.
Yes,
And
precisely.
I think in this group, we're actually going to go back to that.
Yeah, I'm
And
an
I see a lot
old-timer,
of
right?
traction in that direction.
You don't have to implementation of the stuff. You can last call an IGP draft because most likely you forgot, right? Things are hard. So yeah, so I see no reason to go and last call the thing just to have a document that goes last call.
Good. All right.
Close.
Other
Discussions?
comments? Anyone paying attention in the room? Anybody awake? Have to play that song again?
No, so no fun. Okay, cool.
No,
That's
no.
it. Thanks.
All right, thanks. Yes, Mr. Ice. You have to start with a song.
Song. A dance as well. Song and a dance. Good morning, everybody. Good you're here. So my name is Ice from Cisco. I'm working with Pierre here on this draft. So this is generic multicast router election on LANs. Next slide. Now, so over time we added more options than just PIM, right? For both tree building and overlay signaling, right? So PIM we all know, right? So there's MLP, RSPT, and now of course also BEER. Also for the overlay protocols, there's a whole bunch of options, right? PIM, MLP, Lisp, IGP. So that's a draft also I'm working on with Pierre. So you can actually have many combinations here, right? But it's actually only one of these protocols actually that implemented DF election on LANs. So next slide. And that's the problem we want to resolve. So when PIM is not deployed as either tree building or overlay, so who's going to do DF election on the LAN now? Right? Of course, we can run PIM still for DF election, but that seems a little heavyweight just to deploy PIM for DF election, right? Also, if you have multiple overlay protocols, one router maybe is doing BGP, the other one is doing IGP. Also, is it possible to do a DR election among these protocols, right? You can't really today. Next slide. So, and this is the problem we want to solve. Hopefully that's kind of obvious to you guys. If you got a receiver dually homed to 2 routers on the same LAN, both of them will get the IGP report, and both of them will potentially be forwarding the packet out, right? So that will cause duplication on the receiver. Right, next slide. You got the same problem on the source side, right? If a source is directly connected to a LAN with multiple routers connected to it, both of them actually pick up the packet and forward it into the multicast domain, again causing duplication on the receiver side here on the left. Next slide.
I don't think that's true.
So quickly looking at IGP version 2.
Separate case is not true.
Any comments, Craig?
I'm not convinced this is as much of an issue. This one clearly is. This is obviously a problem, right?
Yep.
Because we get a join who propagates upstream, brings those packets down. But in the source case, it's really who's got the join from the other side. This is not like BIDR where you actually DF and bring it up towards the RP. Should be still membership triggered, we'll say, based on that other side. So whatever the overlay control plane is, it should select A or B. And then, because there's no guarantee that these two routers will see each other.
There's only for S, G potentially then.
Pardon me?
That's only if you have S, G joins actually landing on one side.
Oh yeah, I forget when to, let's not break up that soapbox. But
You started. You started.
Okay, so you're saying if we had star G joins for each one of those, who's going to be that member for the source?
Yeah.
How do these two routers then know that they're serving the same multicast domain downstream? They may see each other on the LAN. They may be serving 2 different downstream multicast networks. They both get star Gs from each domain. They both are supposed to pick them up.
Yeah. If that's the case, so maybe that actually we have to take into account when we do the procedures for DR election or DF election in this case. Now, looking at this piece of text from the IGMP v2 specification, it actually says that, well, if you got two different protocols sitting on top of your IGMP, right, you don't want both sides to be a querier because that could cause duplicate reports to happen, right, or duplicate query messages going on the LAN. So they actually put the querier election mechanism in IGMP, which I think was the right thing to do. However, we actually got the same problem for the RDF election, right? If you got multiple tree building protocols sitting on top of your IGMP, you have the same issue, right? Who's the DR, right? If they both individually select the RDF elections, you may end up with two. So I think it was the right approach at the time, but actually they also should have added the RDF election there at the time because for the same reasons. So getting to the next slide. So this probably doesn't come as a surprise. So what we're proposing in this draft is to add the RDF election in IGMP. And if we do that, that's a good thing because then we don't have to do DR elections in each of the overlay protocols individually, right? Because we have a whole bunch of them. It doesn't make sense to add the same logic in each one of them, right? And they all use IGMP at one point in time. So it's good if the RDF election actually is an IGMP because it's also election that is based on group address, right? That IGMP has that information. So what else? So also, as soon as a router is elected as a DER or the DF, right, it can then also choose the protocol it wants to use to get those packets down. Right. Next slide. Now, as I mentioned, the querier, so there is some sort of election, right, the DR querier on a LAN. So you could potentially reuse that to say, well, this is also my DR or the DF. But the specification really of the IGMP querier is very loosely defined, right? So it's not very strict. So we don't really want to use that for the RDF because I don't think it's good enough. Also, we probably want to add like whole time advertisement and maybe some more TLVs or attributes, right, to influence the DR election. And maybe we want to do DR election on a per group basis so we can actually, share the load. Right? That would be a good thing as well. And of course, the election is only going to be done between the routers, right? So there's no host modifications necessary to do this, right? Host will probably see your reports, or probably not actually. But they should not get involved in the DR election. As you've probably seen in the draft, right, we didn't really add, the election mechanism itself, right? We didn't add packet types and so on. At this point, this draft is really a requirements document to get on the same page with the working group that this is how we want to solve the problem. And after we agree on that, we can actually add the procedures, the packet types and how we exactly want to do this. So I also presented this at the PIM working group. And we probably can discuss this a little bit to see where this belongs, right? Now, the requirement is really, well, this is written as a beer working group draft because it's the beer working group really driving this requirement at this point, right? Although this is more like multicast procedures that we're changing because this is not specific to beer, right? If you have MLDP sitting on top of your LAN directly connected, you have the same problem, right? So this could also help you with an MLDP deployment. So in that case, it's generic, right? But it's really the beer work that actually drove this requirement. So that's why I decided to do it initially as a beer working group document.
So I probably know the answer here, but I ask you anyway. This is not a unique beer issue, but I think it didn't come up in MLDP primarily because it's all provider core. We don't have hosts directly connected PEs, right?
Exactly. So beer actually is more suitable to deploy it end to end from a directly connected source to directly connected receiver. That's why this came up. MLDP is not really used that way. MLDP is much more a provider's core where you don't really have that so much. So that is a good point. Yes.
Stig.
I think we should name.
Name? Go ahead. Name. No.
I think we should do it because it's an extension to IGMP and it's generic.
Mike. Can you go to the mic? We're barely picking you up at the mic.
Okay. I think we should do it in
It's off.
Turn it on. There we go.
Okay. So yeah, Stigmanas. I think we should do it in PIM because it's a generic problem. It's an extension to IGMP, which we are working on in the PIM working group. Also, we have experience with DR election and this load balancing and all these different things that you might want to do here. So it's certainly very useful for beer. I understand you guys need it, but I think like we have the expertise for working on this problem and the PIM working group.
Jeffrey Dong from Juniper. I also think it should be done in PIM. Additionally, there have been some other proposals in PIM working group to enhance PIM DR procedure. I'm thinking maybe those PIM DR enhancements could be folded into this as well, instead of developing those PIM specific procedures.
But wouldn't that just put the requirement back to running PIM in those interfaces? I mean, the intention here is if we need IGMP because our host already connected, but we have no PIM downstream. So why run PIM?
No, I mean the proposed PIM DR enhancements could be folded into this. So instead of
gotcha.
enhancing the PIM DR election, just enhance this and then require using this.
These are generic enhancements that could benefit here.
Yeah, okay.
Yes.
Okay.
Yes, Tigvanas again. So yeah, basically it's not PIM, but it's very much the same problem. And if you define this the right way, I hope that it will be easy to reuse whatever mechanisms we have in PIM.
So no, Greg, is that, I haven't read the draft, so I'm asking for clarification. Is that looking at rebuilding a new mechanism to run those interfaces?
The new draft that was mentioned is just how do you basically gracefully change to a new DR if a new DR comes up, or if your primary DR or current DR goes away.
Gotcha. So it's more about the mechanics itself.
Right.
Where those mechanics exist or will be implemented has not been defined.
We also have a solution for like DR load balancing where you can have different groups on different DRs.
Cool. Okay.
And that's also something that could be used here, I think.
Excellent.
We just need to find a way of doing the same thing as we do in PIM and IGMP.
So let me jump in, Tony P. So something very similar is being done on EVPN, where the DF election is being fixed up with a lot of requirements like, what do they call it? Non-revertive bits and so on. So that's a good place to look up how they screwed it up and try to fix it up, right? Thanks.
Sandy, look at
With who are you with?
Second.
Name and association.
Sandy from ZTE.
Okay.
Look at the second sentence in this draft. I can see we will advertise hold time advertisement and per group DF election. My question is, will we advertise the group in the packet of query?
Potentially, yeah. But you have to work on these election procedures, right? But if you want to do maybe a DR, let's say a group-based election, right? So it's more like DR per group. Then maybe we will. But you have to specify these procedures. We haven't really worked that out yet.
We will advertise in the packet, so everyone will know.
You mean in the IGMP hello?
IGMP hello. Okay.
Yeah. Maybe.
Vigor from Huawei. Sorry. For the access side, for the multi-homing access scenario, there are active standby and active access cases. Yeah. In your solution, it is only for active standby scenario or for active.
Well, so we haven't really specified the solution yet, right? So we need to add those procedures on how to do the hello mechanism and do all those procedures. Right?
Have you read the draft?
No.
Okay. It's more of a problem statement, in a requirements draft, and it's to see the discussion here on what we should do to solve this problem.
Yeah, I want to know, will you also cover the EVP DF election mechanism?
Well, yeah, that's what Tony said, right? So we'll look at those procedures and we try to come up with the best mechanism, right? That is suitable for us.
Right. I think we all agree we'd like to have one tool that solves as many problems as possible rather than a whole bunch of granular sets of tools in the box.
And we'll learn from what was done in other working groups. Right?
Okay. Okay.
So this is not HomeNet. Please don't invent the protocol on the mic. Okay.
Thomas Eckert, would this also potentially be useful in an MVPN environment where PIM isn't used, but only BGP?
In an MVPN environment, you mean in the core network? Then
Well, basically on the edge routers where on one side you may only want to have IGMP, but not PIM routers downstream because, nobody
Yes.
cares about it anymore.
I think it would be.
Let it overrun, right? Because that will be still defined with notification. So as long as it's
Any more questions?
just let it run.
Oh, I thought you were coming to the mic.
Yeah, Ilya Melanox. Does it potentially change the snooping procedures in the layer 2?
Yeah, so that's a good point. So if you do PIM snooping, yeah, then that would not work. But yeah, not sure who uses PIM snooping. It's deployed, but that's a valid point. Yeah.
Any other questions?
So we're all good.
So let's get a sense. Anyone have any strong feelings that the work needs to take place here in beer? You think it needs? Okay. Anyone have objections to it taking place in PIM? All right. Interested why? Just
Oh no. Well, I like this work to be done in the group where there's the most energy to do it. That's my only.
so right. That was kind of what I put out yesterday in the PIM group. But I like the potential of having a weapon to pound the PIM guys over the head with. Delegating from our group needs, I think, could be a good thing.
Stigvana. So whatever we do, though, I mean, the draft can be presented and discussed in both working groups and
should be wherever it lives. Yeah.
And it would be great if some of you guys stopped by PIM sometime and.
I was there.
Yeah.
And he presented.
Okay.
Well, no, but I think that's a good idea. If it gets more people crossing between the boundaries, right, it helps the overall community as well as the work we're doing here.
Could you just ask, so who was in PIM yesterday? Okay.
Yeah.
Pretty
So
much the
there's a
same.
little overlap already, which
Yeah.
is probably most of the energy that's going to be doing the work anyway. So, all right, we'll
think about it.
let's, we have to ultimately take it to the list, but Stig, do you see this as something to adopt as a working group item in PIM? Was that actually questioned in the room?
Oh, the thing is, we don't.
Yeah, Mike.
Stigvana. So the thing is, the draft right now is very, very empty. There's no content really. It just says this is a problem. So I don't think it's, we can't discuss adoption yet. But I mean, there was interest in the room and there's lots of interest here. So as long as we have energy and people that want to solve this, I don't see a problem adopting it.
Is the DR election enhancements in PIM active work right now?
We have one draft that might be adopted. There was good support in the room. We'll check on the mailing list. And we have another draft like this DR load balancing, which is a working group draft and should be ready for publication, hopefully in an IETF or two.
But both of those are enhancements to the PIM DR election itself and not just a generic DR election.
Right, but we can use the exact same procedures if we elect DR in some other way. I mean, it's hard to say exactly, but if you do something in IGMP, like sort of like an IGMP hello or something, and you announce some DR priority, and we make that look similar to what we're doing in PIM, then we can easily reuse those mechanisms.
Yeah.
Okay.
So just let me just.
Oh, who's the PIM AD? It's the same as our, it's under routing. Yeah. Yeah. Well, they share. I mean, I don't know. Do we have an AD here today? Oh, we do. Good morning. So who is the assigned AD for PIM? Okay, so we got a load balance here too.
But
Do you have any strong opinions on?
What I have seen of this looks like it would be better in PIM. I'd like to keep your focus on the essentials. But that's something to talk to Aurora about.
I think what they may need is a lunch or a breakfast with the EVPN guys, right? So they all cross-pollinate each other with what they're working on. It is so brutally similar, and then all the same problems will come up.
I'm sorry, you take that to the mic, question?
The comment was, I believe Trill has the same issue, so.
So
multiple attachment Ethernet LANs is a common problem.
Okay, is Trill actually have an active effort trying to solve that problem or come up with a solution
I
in some
think
way?
that I would have to go back and check, but I believe they have their own means of doing a designated router election.
Yeah, see, we need to
I guess
to control this, and that's an AD work
got a
problem.
lot of drafts to read, I think.
Yeah. Well, and there's a lot of evangelization needs to take place so we can get this work consolidated into a single solution.
Even though there's a word DF here, this is vastly different from the EVMPM DF. Just it is.
One guy has to forward the stuff. No, that's just fine.
Yeah, Elias. So I can take a look at the draft and talk to Alvaro about where he thinks makes the most sense. If it has more general applicability than beer, it's pretty clear that having it in PIM would be better. And there's a lot of stuff to do in beer for the architecture and getting the basic pieces together. This feels like it's not quite as central.
So maybe last one question. Anybody feels that this solution should not be an IGMP? Because really that's what I want to get with this draft, right? To make that we're not adding these procedures to IGMP and then somebody says, well, we're not going to accept it because we don't like this to be done in IGMP. So speak now or hold your silence forever.
Let the minutes say no hands were raised.
Okay.
All right. Thanks, guys.
You'll find out. Pointing at your eye.
Ow. There you are.
In Prague, we discussed OEM requirements, and one of the requirements for beer OEM was that to prevent fragmentation, we need to do path MTU discovery. So this is proposal to address this requirement. Nah. Oh. Okay. So if want to use existing method of doing path MTU discovery over the multicast domain, what you can see, actually it should be animated, but I'll try to walk it through. So if root A sends first probe with a packet size of minimum of its links to the domain, then we assume that all links have the same MTU size, but only one link B to D has a smaller MTU that it can process. What happens is that the packets, the first PMTU Pro packet flooded to B and C, and then E, F, and G will respond with their acknowledgement will be positive. Thank you. But B will send back packet too big. A consecutively reduce the size of the probe and send another one, and it will be flooded again to B and C and throughout the domain. So all others will be compelled to respond. As you can see, there are a lot of flooding of the packets. What we're trying to do, we're trying to optimize it using their beer architecture. No, I think it doesn't work. Thank you.
Just say next slide.
Okay. Proposed solution. So we propose to add data TLV to the beer ping, which is just to create arbitrary size of the probes, and use existing bit map, bit string to define the destination, and then the responding The BFR, which cannot forward the packet, will use what is proposed in a dear ping echo reply and will specify their egress BF routers that cannot be reached. So that will be sent back to the root, and the root then can address this failed routers, BFRs, selectively. So if we can see that that's reducing the size of the packet, we can more effectively do the path MTU discovery. If we can go to the next slide, please. There could be a case when BFR does not respond, so their PMTU probe will time out. We suggest that root will decrease the size of the probe, but there may be a case when the root does not want to reduce the probe, but rather continue sending. That is outside of the scope of this document for now. Can we go to the next slide? So with this proposed solution, what we see is that so our assumption about their sizes of the links are the same. All they're equal except for B and D. A sends the initial probe, the size determined by the minimum size of the link into their given subdomain. E, F, and G will respond to the probe. B will send notification back to A, echo response, indicating that it couldn't reach D. Then A sends another probe with their reduced size of it, listing only D as a target. And D then will respond with a positive acknowledgement with echo reply. Comparing to the existing scheme, that significantly reduces the flooding of the packets. Next slide, please. So we welcome the comments and ask working group to consider adoption.
So, Loa Anderson, this might be one of the stupid questions, but isn't this problem solved before somewhere, like in IPv4 multicast or something? Wouldn't there be the same problem?
Well, the problem was the same, but I didn't find there a mechanism in IPv4 multicast to explicitly list their nodes that we want to probe in the multicast domain.
Yeah, Thomas Eckert, to the best of my knowledge, there was never a good scalable path MTU discovery for multicast, which is why we even put into the socket APIs the strong recommendations to, use minimum MTU like 1280 in IPv6. And I'm not sure if there's anything in BEER that would change that, except for maybe saying, well, the domain is more constrained, but when we do that, I'd certainly love to see that we also revisit and explore other options to do path MTU discovery, like, sending it proactively through the IGP or something like that instead of all this probing stuff.
Okay, I believe if using bitstring the BEER, because we can explicitly specify their BFRs that we're targeting, and then using this extension that intermediate BFR responds to their root with their specifying which nodes it failed to deliver to. So that significantly reduces the number of flooding to the path MTU discovery within a given subdomain. So the algorithm converges.
So I think in the first question, is this only an OAM thing that somebody does off path, or is this something coupled also back to the the application, right? Would you think that on the Ingress side, BFIR, you do fragmentation or not, right? So because that takes it, I think, out of OEM into, you know, the forwarding plane discussion.
Well, okay, because currently we have more developed beer architecture for MPLS, and MPLS doesn't do the fragmentation. Yes, clearly this is OEM because the requirement is listed among their other requirements for beer OEM to do path MTU discovery.
I don't think that normal path MTU discovery is, you know, in unicast designed to be OEM. If you basically have a system that tries to do fragmentation based on it, but that's just, you know, how we call the thing, right? I think that's independent of whether we want it or not.
So, Eric Nordmark, so the historical note is that IPv4 has nothing, right? Because there's no ICMP errors returned for multicast packets.
Right.
For IPv6, if memory doesn't fail me, I think it's designed so you can get packet too big to multicast. I know of nothing that actually uses that, right? So you're sort of on your own here. But there is an interesting question which relates to the fragmentation. Is this just OEM or is it something that you could actually use sort of, would the host see some error if it sends a packet that's too big, right? That crosses a beer domain, or is this purely across the beer domain for OEM purposes?
Okay, thank you.
So, Lo Anderson, and can we go back to the slide with the figures on it? So, just to see if I understand your scheme correctly, if you're sending to EFG only.
No, originally.
No, wait, no. If you were sending to EFG only, would that result in a different MTU size as compared to if you're sending to DEFG?
Correct, yes.
Okay, that means that you need to keep a record of the MTU size on A for every possible combination of
it's not for combination, it's subdomain, because if we want to say that we have only distribution to EFG, that will be a different beer MPLS label. That means it's different subdomain.
But for each subdomain, you need to keep track on the MTU size.
Right.
Okay, so
because it's different distribution tree.
Sure. I think that the approach so far in other similar schemes has been to actually use the minimum MTU size, and that would work.
Well, actually, that's a good suggestion. So maybe we can say that, yes, we may select the minimum of all MTU we discovered.
And I think you would be forced to do that if you have a non-compatible LSR, or whatever we call them, BFR, in the path.
I consider that non-compatible will be if it doesn't support this extension and would not respond with their unreached destinations. So thus, yes, there should be some heuristics and on A to do this decreasing the size of the probe, so to finally find out and get it through without help from the intermediate BFR.
Yeah, on BFIR, you would be able to
name, please.
Andrew Dogan Alcatel. On BFIR, you could do it per subdomain. You can do it per channel because each channel may have a different distribution tree. So that's just local. The key is to have a mechanism that will allow you to discover the MTU towards BFERs, and then you can use it depending on how your distributions tree are. And you can, that's, I don't think we would want to standardize this, but we would, if you have all the information, you can decide either to do it once, discover it once for the entire session, use minimum for everything, or discover it based on the channels you're distributing, and then use whatever you've learned per channel.
But Andrew, what you mean we wouldn't standardize it? We wouldn't standardize how do you run the procedure?
Yeah, we standardize the procedure, but we wouldn't standardize how you use this on A. Yeah, like if on A I have two multicast channels, one goes to all four of those DEFG, one goes to EFG. I could use different MTUs for those two
Yes, so
channels, or I could
how
do
you run the
minimum for both of
mechanism,
them.
right? So,
Yeah,
so as
this we wouldn't standardize, but the mechanism we want.
Right.
We
Okay.
wanna have.
Agreed.
Yeah.
So as Law suggested, so if we have two sub distribution trees, E, F, G, and D, we can say, okay, we do it once for everything, and that will give us the minimum for this domain.
So I was
Or
not
two.
looking for a solution. I was just looking to what we need to consider going to the solution. So I think I'm fine with both with those answers.
Yeah, so I may be missing, but as far as I know, we haven't done, even for OEM, path MTU discovery and multicast solutions in, let's say, comparable networks in before, like in MPLS or so, from that perspective. And the requirements document right now doesn't talk about MTU discovery, right? So I think the urgency by which is needed would be nice to write that down a little bit more, given that it always comes up, and then never anything has happened in the past before beer. So how important is this really?
Yeah,
So
I think that advantage here is that beer provides their instrumentation that enables to do it in a reasonable
That
way.
is an interesting aspect, but it's obviously not the whole story, right?
Yeah, Greg, I want to add to that Twirless too. Do we have a case where they're doing this for unicast transport network? Because really, this is not really path MTU. It's more like, topology MTU, right? Okay. And as he's pointed out, all the MTU that I'm aware of has to do with informing the application so it could do some modification to the packet size for what it's going to send. This is within the network, transport network itself. So I'm just trying to say, do we have an OEM parallel to this in, a provider network, MPLS case or?
No, I think that no, but I do recall that in some other encapsulations they have path discovery. I think it's VXLAN and I'm not sure about SFC.
Thanks. Any more questions? All right. Thanks, Greg. And next at the mic, Ran Chen.
Good morning, everyone. I'm Ran from RTE. Today, I will introduce a young data model for beer. Next, please. This document defines the young data model for beer configuration and operation. Next, please. Yeah. Since IETF 93, we have discussed a lot with Mahas via conference call, and also received some comments with some experts like Richard. Thanks. And we have changed, update our draft based on the comments. We mainly modified our draft as following. The first BFR ID configuration, we add default BFR ID in beer global. And the second, import IETF MPLS model and change the type of beer label from unit 32 to MPLS label. The third, we redefined the operational state of beer index routing table. Next, please. Okay. As the fourth, we changed the bit string length configuration. We defined two types of bit string length, imposition and disposition. Instead of one, based on the new section of draft IETF architecture, and I think it is more flexibility for the imposition bit string length is defined under the beer global, and the disposition bit string length is defined under the subdomain. And for each bit string length per address family, I think it will be different beer MPLS label. Okay, next, thank you. We also type def the beer basic parameters such as subdomain identifier, site identifier, and the BFR ID. Also, bit string length. The type of subdomain ID, site identifier, and the BFR ID is unit 16. And the type of bit string length can be 64, 128, 256, and so on, as defined in the architecture draft. Okay, next, thank you. Here is date configure tree. This module augment the routing configuration with beer container. This module defines the basic parameters associated with beer, and it contains beer global configurations, and the beer global configurations, it includes encapsulation type. We support multiple encapsulation type, but right now we only defined the default encapsulation type is MPLS, and we also defined the imposition bit string length, the default BFR ID, and the BFR prefix per address family, and the parameters associated with subdomain, like subdomain ID, multiple topology ID, BFR ID, and so on. Next, please. Okay, thank you. Here is control plane configuration. This module augment the routing protocol configuration with a beer. It supports is an OSPF as a control plane. Okay, next. That here is operational state. The operational state we defined the basic. We defined the parameters of beers. It contains BFR ID, BFR prefix, and parameters associated with subdomain. We also defined the bit index routing tables. Okay, next, please. Okay, this is notification. It contains the beer ID collision, BFR 0, and the subdomain ID collision. Okay, next, please. Comments welcome, and we would like to call for working group adoption. Okay, thank you.
Tony P. 2 observations, 1 question. No, 3 observations. Oh, something like this. All right. So first thing, more like the discipline. So I don't see Mahesh. Has that been run through the compiler? Validated that it compiles? That's like the new fad. So running through the validation tools. Okay. Second one, Aliyah, you think this needs a Yang doctor assigned?
Yeah. Yeah, Yang doctor. Yeah. Oh, sorry.
Is there someone?
Oh, sorry. And okay, sorry. It takes me a while to get to the mic from the back.
We need more mics.
No, I just need to stop front. Aliatlas, I know you could certainly send to the Yang doctors and see if somebody is interested in viewing it. It depends how mature it is. Also, the Yang doctors have been having assistant sessions on Sunday afternoons at IETF. And if you haven't taken it there to talk to them about it, you really should.
Yes.
They're awesome.
Thank you.
Okay, good. So it needs to go to the Yang doctor, be ran through the validation tool. And the third observation, I think it will need work because beer is not address family dependent, right? So the model doesn't seem to be fully aligned with architecture. So that's the 3 observations questions.
Okay, thank you.
All right, thanks.
You say it's not address family dependent, but you do associate your BFR ID with a loopback address, right, which you announce in the IGP. So in that sense, you still have to look up your bit in a particular table, depending on which loopback address you're associated with. So I think there is an address family dependency here.
No, I saw a subdomain having actually underneath which address family it runs in two different labels. Whereas nothing prevents us in the subdomain today just forward both. You just put what is the proto in the frame.
I think you do have to configure, let's say, which address family you support.
Okay, so address family is under what? It was under subdomain, right? So see, under subdomain, it kind of defines which address family. A subdomain can carry both address families.
Yeah.
Oh, you mean it? Well, okay. Yeah, so address family should be on top and subdomain as a subsection of an address family.
I don't know, but that looks backwards to me. I mean, a subdomain is not restricted to address family, right? We can carry MPLS frames in beer. We can carry any AF, right?
It's both. Right.
Okay, so yeah. I have no opinion. Just looked to me like an anomaly. So didn't look like that has been deeply looked over whether it aligns with architecture.
Yeah, this is Fang Wei from GT. So here I'd like to clarify the address family. From the basic build specification, it can support IPv4 and IPv6. So here we define the different BFR prefixes for IPv4 and IPv6 separately.
Yes, but the label will be the same. So I don't see the need to differentiate, on different labels and different AF. I mean, the beer frame tells you which protocol is behind it. So subdomain can carry anything, whatever you carry to specify it as the protocol carried, including OAM by now, right? But we're inventing protocol on the mic. I'm just pointing out it doesn't look like it has been deeply reviewed, okay? So there's three things. This needs to review someone who is deeply steeped in the architecture. I mean, we need the model. No one escapes the model by now, right? So we need the model, we need the Yang doctrine, the validation. Okay, so who likes to work on the Yang model, people? Like, it's no, new careers.
I'm sorry, Mike?
Mike.
Peanut gallery. Peanut gallery.
Oh yeah, I guess I get to do encouragement to back up Tony for looking at this. Given that beer is a new technology, given that by the time it progresses, the use of Yang models as opposed to MIBs is going to probably be, I mean, you can guess your own industry trends the same way I can, but I'm betting you're going to be looking at using this to operate beer. And given that one of the benefits of beer is supposedly operational simplicity, it's really good to make sure that the model matches up with your architecture and that you're paying attention to it. There is a reason we are doing Yang models in the technology working groups, and it's not to give you all 15 minutes to read your email. Please do review it.
Thank you.
So do we sense the move for adoption?
Yeah, I would say so because
yeah. Exactly. So first of all, thanks. This is something we know we're going to need, and having people jump in and volunteer to do this is exciting. Okay, Torlis, go ahead.
Yeah, I mean, as much as I had working on this, I think for TE it's even more important because there's a lot more configuration that would need to be pushed down by a controller.
Excellent, and that's a call for a volunteer from Torlis to help you. So that was perfect. Thank you. So look, at sense of the room, who thinks this is a document we should adopt into the working group? Show of hands. Okay. Who is opposed? Excellent. All right, good. We'll take it to the list. Thank you very much.
Thank you.
And thank you, Torlis. Next is Torlis. Come on down.
You want the raise pointer?
Yeah, it works well when you push the button.
All right, so we had some good discussion on the mailing list oops, I didn't press anything.
Stop it. What are you doing?
I'm not doing anything.
Holy smokes, Torres, what are you doing? Go ahead. Go ahead.
Okay.
It was funny. It doesn't work right.
Okay, now it doesn't work either. Oh, you mean just the laser pointer is working? Okay. Next slide. One beer too much for Chet yesterday.
Cool. Next slide.
Next slide.
Okay.
All right, so basically 3 big blocks. So yeah, knucklehead stuff. Then basically in the O2 version, refined the explanation of how to save bits when you have rings. So basically what we originally had in there was just an explanation of how you can get away with a single bit for a whole ring to flood things. And that's good enough if you want to send traffic only in from one, let's say, pair of redundant ingress nodes and use the ring to distribute to all the other nodes in the ring. And we basically added all the explanation on how to use it with 2 bits if you want to inject from any place, because it simply means that you now have 1 bit that sends packets clockwise around the ring, 1 bit that sends it counterclockwise. They both terminate at one part in the ring, and so every point that you enter the ring, you can simply set up the 2 bits accordingly that the packet will now start to be sent in both directions around the ring and then stop at the stop location. Sorry, no picture for that, but I can do it next time. So the main work was really around understanding how to deal with the set identifiers, subdomains, and BFR IDs in BRTE. Next slide. And so that's basically what I tried to do, and it turned out it was a lot easier to put that all in a new section. So the first thing aligned the definition of BIFT with the BR architecture. So every subdomain in BRTE has a single BIFT like in BR, and the index is the set identifier and bit position concatenated. So, you know, if you have a bit string length 256, you have to up to 256 of the sets, so 64,000 indices in the BIFT. Now in BR, every SI bit position is a BFR, so a BFR ID. So you see in the BR architecture also simply the index being the BFR ID, and that's effectively what, unless we, you know, change the way on how we think about it, BFR ID would be slightly different in BRTE. So what is a BFR ID in BRTE? Well, BRTE doesn't itself require any BFR ID.
So I think that we discussed this before, right? But in traffic engineering, there's no set ID.
No, there is a set ID. I really need
there's subdomain and bit positions.
No, I need the set ID. That this is basically what this says. I'll walk it through.
Okay, I'll wait then.
So in BRTE, we do not care about BFR ID in the forwarding, right? But the BR encapsulation and the flow overlay, they both want to know a BFR ID, right? So you have the BFR ID in the header, for example, for the upstream label checking in MVPN. And then, of course, also in other flow overlay signaling, the BFR ID would be used. So in BRTE, every bit position in a BIFT indicates some adjacency. That can be a BFER itself, a group of BFERs, transit adjacencies, right? So all the things in the topology of interest. So there is no simple one-to-one mapping of bits to the BFERs. So how do we now deal with the fact that BFR IDs are really for BFERs? Next slide. So in BRTE, every BFER will have 1 or more unique bits that are never set unless you want to send the packet to that BFER. So think, for example, about a leaf BFER, meaning one that is not a transit BFER. It has 2 links going to it. Each of the links has a bit for it, right? So the node itself doesn't need a bit, but you have 2 alternative paths you want to engineer. So basically, these 2 bits are exclusively set. One of them when you want to reach that BFER. So basically, the BFR ID equivalent to that bit position, let's say the lowest one of them would be the BFR ID of that BFER. How do I translate those? So if I basically want to start translating from a set of BFR IDs over to bit strings, let's say on a BFIR that is trying to calculate a bit string for BRTE. So there are basically two ways on how you can think about traffic engineering, right? So the simple traffic engineering, which would be similar to, let's say, shortest path tree, where all the branches to receivers are independent of each other. Basically, for every BFER, you have a set of bits to reach that BFER. And if you remove that BFER, well, you don't need that branch anymore, but the branches to the other receivers are unaffected. So what you can then do is that basically you have a mapping table from BFR ID to a set of bits. And if you want to send a packet to multiple BFERs, you basically just OR the bits, and that's your bit string in BRTE. Now, if you have what I call interdependent branches, and there must be better terminologies, but I haven't found it. So if you have something like a Steiner tree, which is kind of the sum of the link metrics, should be shortest. It means when you add and delete a member to the distribution tree, the path to the other members might change. And that basically makes it more complicated. That basically means that you can really only translate the whole set of BFERs you want to reach to a bit string. And that would be in an appropriate place like a controller or other entity that we may want to define. Can we translate back? Yeah, sure, we can translate also back, but I haven't bothered about that because usually we do not see the actual bit string on a receiver because the bits are being reset like in BEER. So translating back from a set of bits to the BFR IDs, I think, is not relevant. Next slide. So how would BEER use SIs, set identifiers versus subdomains? And so this is my best understanding from BEER. And the idea was to make BRTE behave as much as possible the same so that the surprise is minimized when trying to add BRTE support in a solution. So there are really two main aspects, right? So they're basically the aspect of having additional subdomains for replication efficiency. So usually I think we'd assume that subdomain 0 is covering all BFERs. So any service could use just this one subdomain, but you may want to create additional subdomains for services that are requiring to only work with a certain subset of BFERs because you can achieve more replication efficiency. And I have a slide to show that. And it's quite simple, right? Depending on where the BFER IDs are distributed in the network, you may need to just send to a small number of BFERs, but they all have a different SI, so you're sending many different copies. And if you only ever have in your subdomain the BFERs of interest, you will have much less SIs to deal with, so fewer packets to send from the BFER. The other aspect of SIs versus subdomain is that SIs are transparent, right? So the flow overlays, they only deal with the BFR ID and the subdomain IDs, right? So they don't, in normal life, need to distinguish between the bit position and the SI. And that makes it kind of easier to deal with BFR IDs, and then probably every instance of a service you need to configure to use one or maybe even more complicated multiple subdomains. So my conclusion of that was that SIs are simple, subdomains, certain things like configuring specific subdomains for a service is fine, but let's try to avoid requiring more subdomains in BRTE than we require in BEER. Next slide. So here is a broken picture of a topology. Okay, that's bad. So the idea is we have a large topology, and we basically have a core here in the network. I think the core is broken, but let's assume it's fine. We have in each area, we have 6 areas. Each area has, let's say, 200 BFIRs, and then each of the areas has 2 edge routers into the core, A and B edge router. Next slide. So I hope you folks can see this. So I basically now try to show with, let's say, something like BEER, if we would assign the BFR IDs so that in each area, the BFERs have bits with one SI set. Then, next slide. And I hope that works well. Kinda. So what you see here is that you are sending out 6 copies of the packet, 1 for each set. And as you see nicely, the copy for each set just goes to the area and is being replicated in the area. If we now would, have other assignment procedures, let's say random assignment, next slide, and I'm just showing this in this area down here. Okay, right. So in this area, we would be assigning BFR IDs in this area from all the different SIs, from the 5-6 SIs we have. Then you see you're sending across the border routers into that areas up to 6 copies instead of just 1, which may or may not be something you would like to have. Next slide. So BFR ID, it's in the name, right? We would like it to be just an identifier, but if the network becomes large, it can be helpful to assign the BFR IDs with location of BFER in mind to save bandwidth. And one way to think of it is that the set identifier becomes something like a locator in a larger network. And if that's something in a large network you may need, then obviously it's also good to think about the future, because you may plan perfectly fine and then you expand your network and it breaks down because you haven't left space in set identifiers. So with that in mind, I think it's easier to see now how this becomes even more important to deal with in BRTE. Next slide. So before going to that, right, why do we want to have BRTE in the first place? And here are just a few examples of the things that BRTE can give you better. Namely, and that's basically what I wanted to show in the way on how to set it up with BRTE, with the fact that you can in BRTE explicitly engineer how the traffic is being load split, right? For example, here in this picture, somehow we got a load splitting that 2 of the copies here go across the left BFR, 3 across the right one. But whether or not that's actually true, right, is down to the magic of ECMP. It also may not even be down to the magic of ECMP, but everything may just go on one link because you may not have ECMP within this area down to the sending BFR, right? So you may get the traffic just only across one link if you don't even have an ECMP condition. Or basically, as shown here, you may unnecessarily be sending 2 copies in because, well, now you do have some form of ECMP that basically makes different joiners down here go into either one of the BFRs. So those are just explanations of how basically controlling how the traffic is being sent across the edge routers via the core is one of the benefits that BRTE can give. Next slide. So what do we do, right? So in addition to setting up the bits in the BIFT so that the SIs for the BFRs in the different areas all have basically colors SIs that are for the area, we're also doing the same for the bits that are for the intermediate hops, right? So basically, you're setting up in each of the areas bits for the intermediate hops to do your traffic engineering in the area. That goes all the way to the edge routers of that area. And then next slide. If you send the traffic, what you're doing is you're basically having here on the ingress BFR a routed adjacency in beer that basically sends the traffic directly to one of the edge routers. And from there on, you have other adjacencies. So the result is fairly similar to what you saw in the beer picture, except that with this setup already, you can, of course, explicitly select, do I want to send this packet across this egress edge router or that egress edge router individually for each of the areas. Next picture, next slide. So now if we set up even more bits, so in this case what we would be doing is for each of the edge routers we're assigning then a bit in each of the SIs. Then what we can now achieve is we can basically do the engineering even better. Next slide. So what we can now do is we have 2 routed adjacency, and so by setting the appropriate bits here and here in the packet that we're sending in the bit string, we can now achieve that a packet is being sent across one of the 2 chosen ingress edge routers and across one of the 2 chosen egress edge routers. Right? So this is basically an example of how to do the traffic engineering across 2 hops and just a small number of bits have to be reused across the different SIs. The majority of the bits are just the bits within one area that are not overlapping in the topology. So this is just an example of a fairly efficient assignment scheme in larger networks in BRTE, because that was one of the questions: how can we basically make BRTE scale in larger networks? And that doesn't require changes or enhancements in the forwarding plane we'd already defined in the prior versions of the draft, but just in the appropriate use of the bits and setting them up. Next slide. Okay, this is basically here the summary of that, and I think, next slide. So the last question in this space was, how do we basically use subdomains between BR or BRTE, right? So the most easy way is to say that a particular subdomain has either BR or BRTE forwarding. Then it's basically a per subdomain attribute, and that makes sense because in BRTE we basically need a lot of the bits for the transit, not only for the BFER. So basically, if we were sharing the bits, if we would allow forwarding in both of them, BR would become less efficient because some 20 to 80% of the bits would not be usable in BR, right? Now we could share the subdomain, but as I said, I'm not sure if there is a benefit. So would certainly love to have some thoughts and feedback on that one. Next slide. I think that was it. Thank you very much.
So, ICE. I think you're mixing semantics from shortest path BR with traffic engineering that are not compatible. So I don't think you should use a set identifier here, because if you take, for example, BFR ID 1000, a bit string length of 256, that would end up in set 3.
Sorry,
now,
come again?
A bit BFR ID of 1000, for example, right, will end up in set number 3, for example. That node is reachable via shortest path because all the nodes in the path learn about that and they create a forwarding table for set number 3.
Okay.
Right? If you use it now for traffic engineering, that BFR ID of 1000, that doesn't mean that any forwarding table is generated in the core of your network to reach that node. You can only reach that node if the bit position for that node is the same as all the bits that you use on the path. Right? So you need to engineer the path to that node using the bits that you have. They need to sit within the same bit string that you have. Right? If you want to do this, you need to do subdomains.
No, I don't get it. Sorry.
What? No? You understand? So with shortest path,
sure,
right? The BFR ID is translated into a bit position and a set identifier that is advertised through the network, right? And that creates a forwarding table, right? It biffed, right, on all the nodes in the path to reach that node. If you're going to use the BFR ID in traffic engineering, that doesn't happen.
Well, I think that's exactly the question. What do we need from, for example, routed adjacency for the labels, right?
Right. So you need to configure on each node now set identifier bit position, right, to a particular next hop, right? But that's not how we use set identifier. That's what we use subdomain for. The set identifier is not something that we configure on each node. It's automatically generated for the purpose of shortest path forwarding.
In BR.
Yes.
In BR, right.
So for BRTE, if you want to engineer it and you say, well, this is my subdomain here and these have the same bits, right? You configure the subdomain. So you're mixing using set identifier and subdomain.
Well, so in the first place, I was coming from the perspective of how do I make it most easy for flow overlay solutions, right, that rely on the BFR ID, not having to deal with more subdomains than they would need to deal in BR, right, to the extent that that is possible, right? And I'm not quite sure that I fully understood what you said about the inability to deal with the SIs when I'm doing TE. So from the way I saw it, that would be perfectly fine.
From a functionality point of view, SI is dynamically generated, right? It's not configured. If you want to engineer something, use subdomains.
But
let's say the semantics are very similar, right? How it behaves.
But you saw in the same way, right, that in normal BR, if I don't start thinking about the SI part of the BFR ID as some form of locator, I'm also getting non-ideal forwarding, right? So from that perspective, there will be an aspect of engineering the BFR IDs in beer as well, in a large network, if you want to get replication efficiency.
Yeah, I don't think so, but we can take it maybe offline and then.
Tony Pizzo, head of. So I don't see anything wrong using a different subdomain and interpret it as a TE subdomain, right? And then the set identifiers can be used that way. It's perfectly fine. It can be used as locator. Mixing the semantics of normal beer and beer tea in the same subdomain. First, I don't know what problem it really solves. Second, it will make the cost of hardware go up exponentially. Right. Third, we need something on the frame to identify, when the frame comes in, what does it mean? What problem are we solving?
Well, the same subdomain that would be possible when there would be two labels bound to every subdomain, right? One for beer, one for BRTE, for example.
But
whether it's beneficial, that's a different question.
But then you reinvent subdomains.
Maybe. Yes.
Okay. You already have we had this huge fight to get precisely this subservice. It is basically an SSAP, right? This is where you distinguish what service are you running on beer. That is subdomain. So we don't need more dispatching points behind that.
Well,
really.
but there's a difference between what service are you running on top of it and what is the forwarding semantic that you want to have, right? If you think you had that discussion, as I said, I'm totally open whether to have beer and BRT in the same subdomain or not. Right now it seems to me easier to have them in different ones. That's fine. Yes, I just think for the flow overlay that I would like to keep the ability to have the larger BFR ID space where I'm then relying on the SI. But let's figure out in the first place if there is technical reason why it wouldn't work, and then if there are no such reason, which is what I think, then the question really is back to what is logically the reason why I would want to constrain myself effectively to a BFR ID space which is far lower than, let's say, the bitstring length. That's what I would get when I don't have.
So I think I may be translating what I said. I do not think that you can mix the TE and the normal beer semantics just using different SIs, because if you have an SI, a frame with an SI which is interpreted as TE, it may pop up your beer frame in a very unexpected place.
No, wait, don't get me wrong.
Oh, okay,
so sorry,
maybe
I'm saying,
no.
So let's say really the simple case, which I think is good enough, which we should go with, a subdomain has either beer or BRTE, but within the BRTE subdomain, I'm also using the SIs to basically support a larger network.
Absolutely.
And I don't want to use multiple subdomains, because when I use multiple subdomains, the flow overlay can't simply deal with one parameter, which is the BFR ID, but now it basically has for every BFR ID to associate another subdomain.
Agreed.
So that's basically what I'm trying to avoid, because then every flow overlay would become more difficult. Now, I'm not sure if there's anything in what I said that will break this, right? So for example, for the routed adjacencies, and so that we have to sit down.
Yeah, but I think it's much harder to manage because the BFR ID is just a value, right? But if you configure your forwarding adjacencies in the core, you need to know exactly what subdomain it is. Sorry, what set identifier you want to program this for. So in a way, you're using it as a subdomain.
But that's an interpretation where I'm saying I'm more interested. What are the priorities, right? My priority is to make life easy for the flow overlays.
Or maybe I don't know.
Yeah. But then as far as the programming is concerned, right, whatever I can get out of the IGP, I like to take it, because otherwise I need to write a Yang model to manually configure it.
But I think you need actually an IGP extension for beer still,
Okay,
right? And there you can actually address this maybe.
I think we're running out of time.
No, it's fun inventing protocol on the mic.
Sandy, I saw in your draft you divide the beer domain into several areas. I wanted to know if these areas equal to IGP areas.
No, well, they most likely would. If you have a large network and your IGP also is scaling challenged, like SPF protocols, then most likely those would be the same areas. But it's totally, there is no necessary relationship. It's just coming from the topology of the network that in BRTE you need to have a consecutive part of the network, within one set, so that you have bits through which you can replicate. And that basically means really trying to figure out how to partition it, and then use tricks like, ingress a few unicast hops that I showed to basically traffic engineer the individual copies into the right areas.
And I think due to you said, no, we can't use IGP error direct to your draft. Is that right?
Well, I think that, the question is a little bit, how would this BRT, management be done, right? So I think that's where all the PCE stuff that's going to be presented will, I think, become quite interesting. But I would think that, however you came to the design that this is the IGP area, you most likely will have the similar process to arrive at, oh, this is also a different area in BRT.
Okay.
And as I said, right, even in beer, it gives you, when you think about it that way, it gives you replication efficiency.
Okay.
Thanks, Forlis. And
good morning, everyone. I'm Sandy from ZTE. It's my presentation for design routing in beer forwarding. Next page, please. And let's see the problem. In beer architecture, we suppose a multicast flow. The ingress node is A, and the egress nodes are D, if, and K. We want to forward the multicast flow to D, if, and K. But according to the shortest path forwarding, the path may be A, B, C, D, and A, E, F, and A, G, H, K. Obviously, it's not a very optimal route. Next, please. The same example, we can see we can use the optimal path. A forward the packet to E, and E forward the packet to if. And if as the crossover node, F will send the packet to CH, and C and H will send the packet to D and K separately. Next, please. Our question is how to let the packet be forwarded through this way. This is the solution. This packet will be encapsulated by path list. This is a flag in the beer header. It indicates that there is a path list behind the beer header. The path list format is a new type of TLV. The packet will be forwarded by the nodes according to the beer forwarding table defined in beer architecture and the path list. Every node on the path list will treat the path list and forward it. Next, please. Let's see the detail of the forwarding. We can see we use several levels to indicate the nodes in the path list. For this example, we can use the level 1 to indicate node E, and level 2 to indicate node if, and so on. CH is in level 3 and DK is in level 4. These nodes are classified by the distance from the ingress node. We can see node E is one step from A, so E is level 1. Next, please. And the path list, all the nodes in the path list will forward the packet due to the path list. And the detail is A checks the path list and forward the packet to E, and the destination of the package is D, if, and K. And so on, the packet will forward to if. If is one of the egress nodes, so if will decapsulate the packet and forward out first, and if will check the path list, forward the packet to level 3 node C and H. And C and H receives the packet. C will forward the packet to destination D, and H will forward the packet to destination K. Next, please. And let's see the forwarding algorithm. A look at the beer forwarding table. The forwarding table is the same as the forwarding table defined in beer architecture. Because the next node is E, so A will find which items next hop is E. So A picks out the item EF, which next hop is E, out of the forwarding table, and A use the destination DF key and the item EF, gets the result and inverse it, and the destination gets the reserve nodes, which includes D and K. What is the reserved nodes? We can see because B must, according to the nodes in the path list, to forward the packet. So maybe some destination nodes will be lost. So we want to get these nodes back. So we can use this function to get these nodes back. A uses the destination DFK and the item EF and all the reserved nodes. And this function will get the lost nodes back, and A will forward the packet to E. And the process in every node is similar. Next, please. When the packet reaches EF, at first it will check if itself one of the egress nodes. Due to the rules defined in beer architecture, so if will decapsulate the packet and forward out at first. And if picks out of 2 items due to the path list, because there is 2 nodes that they will forward the packet to, C and H. So F use the same function in A and E, look up the items in the BR forwarding table and do this function same as E and A and forward the packet to C and H, and so on, C, H. Next, please. And the function in C and H is the same as F. So C will pick out of the item D, and H will pick out of the item which next hop is K, and they will, C and H will forwarding the packet to D and K. Next, please. Let's see the advantage. The forwarding table is the same as the table that is defined in BR architecture. No additional table. The bit string in path list is same as the bit string defined in BR architecture. No addition bit string. When the crossover node is as close as possible to the egress nodes, the forwarding will be most efficient. Next, please. That's all. Any comments?
No comments, then jump in. Okay, Tony P. So Sandy, I think we had a discussion, and it's cute, but unfortunately does not work. Okay. What you have, you cannot topologically sort a graph and express a DAC by just announcing the membership at the level of the topological sort. What you're describing is a lattice, which will lead to duplication of packets. I think we went through the example. So the example you engineered on the view graph will work, but I think we went through the example when I've shown you how you will replicate packets towards the next level from a previous level. So we can keep it on the email, or you can implement it and experience it. So that's my comment. I spend time on clarifying that stuff. Thanks.
That's it. No more comments? All right. And Linda, excellent.
Morning, everyone. I'm Linda from CTE Corporation. This is my first presentation. It's about beer use case in VX9. In fact, it's in NVO3. Okay. Sorry. Yes. Okay. This is the background of this proposal. In fact, it is motivated by beer use cases. In section 3.6, it proposed there are many advantages introducing beer in data center virtualization. So I proposed this draft to describe how to extend current protocols to take advantage of beer in data center virtualization. In fact, until now, I have received several questions, comments, and here I list the comments in the following slides. Okay, next slide, please. This slide is about the problem. As we all know, there are two most common solutions to forward bomb traffic on the overlay network. And the first one is ingress replication. However, it doesn't provide the optical forwarding or multicast. So, and the other one is enable the multicast capabilities in the underneath. But it requires the data center to run multicast protocol and maintain multicast states on the edge routers and all the intermediate nodes. So about these issues, maybe we think how to eliminate above issues. Okay, of course, introducing beer in data center virtualization is really good choice. Okay, next slide, please. This slide is about the solution. Okay, you can see here the main idea is each NVE advertise VXLAN information together with beer information to other NVEs. If you see my draft, you may notice that in my draft, I focus on the IGP or BGP extension about VXLAN information. But in fact, no matter what current protocols, such as some overlay protocols, such as MLD, PIN, or MLGP, is also okay. And here is a figure about the reference reference format of the extension. You can see here the above is the beer info information, and the following is the VXLAN information. And after that, each NVE creates a mapping between the VXLAN network identifier and the bit string representing the other NVEs in the same virtual network, and then forwarding the bump traffic according to the mapping bit stream in the beer header along the beer multicast forwarding path. Okay, next slide, please. Okay, this is a this slide trying to show the beer data center use case in details. And you can see here is a figure. It's about data center. And here has 4 NVEs, A, B, C, and D. And first assign a unique bit position to each NVE and the data center. And then each NVE will advertise beer information plus VXLAN information. And then each NVE creates a mapping between the VXLAN network identifier and the bit string representing the remote NVEs belonging to the same virtual network. Bump packets are received from a virtual network, and then NVE looks up the mapping and encapsulate the VXLAN information as well as the beer information. And then forwarding the encapsulated packets along the multicast path according to the bit. Okay, next slide, please. Yes, here is the patient's comment. This is the first one. It is comment from Andrew Chu. He suggests as VXLAN, NVGRE, and some other, all these data planes are using similar technology to support L2 over L3. So how about using OneDrive to take care of all similar data planes? So that's why I would like to change this VXLAN to MBO3. And he also suggested that change the specific VXLAN network identifier field into 2 sections. And one section is protocol. And the second one is bump domain like VNI or TSI or some more general terms. That's okay. Yes, it is really good idea. So I plan to add this in my next version. Okay, next slide, please. This is a precious comment from Tony. He suggests VXLAN IGP because in my draft you can see there is a big IGP extension, and so and Tony said VXLAN IGP extension will melt down the IGP floating. Yes. So he suggests, what about using MLD or IGP extension described in Pfister Beer MLD to carry the VXLAN information? Yes, I think it is really a good idea. And just as discussed before, some people suggest that use pin overlay is also okay, but you know there are all kinds of overlay technologies, and I hope there are much more discussions in the mailing list about all kinds of overlay technologies, and then we can find the best one to update this in this draft. So, okay, any comments?
So I feel quite uncomfortable
Name,
not to really.
Tolles.
Huh?
Name.
Oh, name, yes, Tolles. Still, of not understanding the use cases, and therefore, you know, I probably don't have the right motivation, and B, I'm very uncertain about the scalability, right? So in the back of my mind, I have this, oh, the data center has millions of virtual machines, right? And hundreds of thousands of virtual network identifiers, and I don't know how many hosts in there. So basically some use case explanation where it would become clear and evident that we could scale to what's needed there would really be great to create the motivation, right? So scale from the number of devices, but also then if this is all, you know, in VXLAN, some unknown traffic, right? Or, you know, broad multicast traffic that effectively still needs to reach every node in a VXLAN, then, you know, yeah, just flooding the bloody stuff is good enough, right? So I was talking with Kaitlin Bessler, she's been on the mailing list also. I understand her use case, that really looks cool, right? In the data center, like a really great match for beer, but that's the only one that I understand right now. So really interested in use case explanations.
Okay, thank you.
Jeffrey Zhang from Juniper. I have not followed up on the comments on the mailing list, but I'm just wondering, today VXLAN can use PIM, basically multicast groups to do these kind of things. So why can't we just use beer instead of PIM trees? But other than that, everything else is still the same. That we use VXLAN, and in the VXLAN header, you have multicast group addresses, and then you just use a beer domain to carry those multicast group traffic across your domain. So no changes at all in either in beer or in VXLAN itself. You just use beer as a transport.
I also use beer to to get together the other MVEs to in the same virtual network?
You could, but you don't have to, because today you have everything already working with PIM-based multicast. Now you just change it to beer-based multicast.
Yes, and this, I think this is a discussion about PIM and beer. Yeah. As already said, the PIM is multicast protocols that it requires the underlay all the underlay nodes.
Understand that.
Yeah.
Yeah. So
But,
now you do not run PIM at all, but you still use group address like 232.1.1. All those stay the same. It's just that you use beer instead of PIM to carry those packets through.
Okay.
Tony P. Yeah, so the membership discovery is pretty much an overlay problem, right? Whereas this suggested to put it into the beer layer, which will simply melt it out and it will shake it for no discernible reason, right? Each VNI membership will cause to reflood, including all the routers in the middle who literally have absolutely no interest in that stuff. They don't even have a BFR ID. Yeah. But otherwise, yeah, I agree. So whether you solve it via multicast or PIM or whatever as the overlay and use this thing purely as distribution layer, that's the solution that will scale. Yeah.
No more comments. Because you mentioned that on the list as well, right?
Yeah.
So I remember that. All right. And one more.
Oh, yeah, still me. Yes. In fact, this is about beer Ethernet. In fact, as in the meeting, they have a lot of discussion about this one. At the very beginning, it is called beer night. And after several discussion, and especially I really want to thank him. And I changed the name from beer night to beer Ethernet. I think beer Ethernet is much more precise to this solution also. Okay, next slide, please. Yes, background. Beer Ethernet is trying to implement beer forwarding in Ethernet network. Okay, next slide, please. Every solution has two parts. One is control plane and the other one is state plane. Okay, next slide, please. This slide is focused on the control plane. You can see here, the main idea is define a new beer Ethernet sub-TLV. And then advertise beer Ethernet sub-TLV together with beer info sub-TLV in IGP extension or BGP extension. You can see here, there is a figure. It is a reference format of the beer Ethernet sub-TLV. And you can see here, it carries the BSL identity file in this sub-TLV. And as for BSL identity file, it identifies the BSL information the sending BFR supports. It may include one BSL, or of course, it can include several BSLs. For example, you can see here, I reserved 8 bits for BSL identity file, and each bit represents one BSL value. Here is the example. Here is the example you can see here, and I just now see the ICE extension. Tony just add a sub beer. Just add a BSL identity file sub TLV in his ICE extension. And thank you very much. Yeah. Okay. Next slide, please. This is about display solution. You can see here, because there requires directions to identify the BIFT table. So there should allocate the BSL information, subdomain information, and the set identity file in the updated beer header. as well as TTL and TOS field. You can see here in this figure, there has subdomain ID and set ID and BSL information. Of course, TTL and TOS. Yes, additionally, mostly this updated beer header is immediately after Ethernet header. So there may need a new Ether type to encode this kind of updated beer header. Yeah, this is 2 points about the data plane. Okay, next slide, please. Yes, in fact, this draft has already discussed a lot in the mailing list and also many offline discussions. So, of course, I will update this draft to using the name Beer Ethernet, and I also think the contents in this draft is already discussed a lot. So, can I call this draft for working group adoption? Okay, that's all.
Any comments, questions? I think a discussion going.
Who read the draft? Okay, those are the selected few.
Hey, Cisco. So we discussed this yesterday, right? A little bit more.
Yes.
But I think we have to be really careful if we introduce another encapsulation for beer, because it's expensive, to get this supported in all the hardware platforms, right? And I've not really seen yet a really good argument why MPLS would not solve the problem, right? I know we had discussions that in data center MPLS is not supported. However, beer doesn't really require MPLS forwarding, right? We just use the MPLS label as a label, which could be implemented as such, right? It's just an indirection into those values that you hardly encode hard, right, in your header. So that's maybe also for the work. And actually, we discussed this before in earlier meetings we had, right? What sort of encapsulation? And so yeah, so I'm not so convinced yet. We need to work on a different encapsulation. If there are really good arguments to do so, then of course we will. But we need to think about this.
Greg representing Cisco again. I think to address that, when people say this particular deployment doesn't support MPLS, it also doesn't support beer, right? So it's going to take a rev of equipment to get there anyway. And so that's your point. What specifically in the label encapsulation is missing that has to be replaced some other way? There's going to be religious issues. We know that, right? And I think we discussed this too. Do we call it MPLS encapsulation? It's almost like MPLS has taken encap and forwarding and smashed them together, and we're not looking at the forwarding. We just want an encap of some kind. So in lieu of an ether type and starting over, right, we're just using label encapsulation, not MPLS.
Right. We potentially have to do a lot of work by using a different ether type, but you need probably replicating a lot of forwarding code that we already did, right? It's just that the name changed.
Mm-hmm. So it may come to a marketing issue. That's right.
Pat Thaler, Broadcom, and IEEE 802 Vice Chair. I think that before one did anything on this, it probably should also be shown to IEEE 802 to see how they feel about putting this directly over Ethernet. So I'd request that if this is adopted or considered for adoption, be a good idea to shoot off a liaison to 802.
Thanks. Good note. All right, do we make a room call?
No, not enough people read it.
Okay.
Yeah. You can spell it with that membership over it.
Well, it has to go to the list anyway, not to the room. The room's a measure. All right, so I'd encourage you all to read that. I think we have some good notes to discuss in terms of what we do long-term in CAP. And, unless we have a use case to move stuff forward, we have to have more participation really to get some feedback on that. So let's keep the discussion on the list.
Okay.
All right. And if we get more people responding, then we can, and we come up with a use case where the labeling cap clearly is not solving our problem, then maybe we can revisit it.
Okay. Okay. Thank
sense?
you. Okay.
All right. Thanks. And that's the last item on the agenda. No one jumped up and ran away. Look at that. Thank you, everybody, for participating. I encourage you to then, pardon me? Yeah. To read what's out there, get the discussion continuing. I appreciate that. It's been very dynamic. Blue sheets. Has anyone not signed the blue sheet before you run away? Everyone has signed the blue sheet? Who has signed the blue sheet? Raise your hand. Busted. All right. Worked. Hey, how you doing? Yeah, absolutely. Well, currently, yes. The architecture itself is not dependent on any given path. Either rear head or actually it's not an MPLS. All we're using in the MPLS label is. Well, no, we have a rear header that has the midstream code. There's nothing in MPLS that has the midstream. We're just using the label as an end cap. Because we have forwarding, we have encapsulation. Right? So not using MPLS forwarding, we use rear header. It's a separate rear header. It's after it's going to be then we also carry earth context. So when it arrives in the packet, it arrives in the next node, it knows it's a beer packet. So this label defines it as a beer packet. It's really as opposed to a dedicated ether type. Right, because right now there's a it's not EP60 type, and there's hundreds more that aren't even used. We go through that step and require all these boxes to support the ether type. When we take this, it has some semantics we can use, well known, and support it. And then makes sense. Yeah. So I understand with this environment where they don't want to run MPLS, but we don't. Right? There's no LDP running. Just in the thanks.